simply did not know. The reason we now know that technology to understand we now know that has more effort. For the first time, we are able just recognizing the spoken language was not very well. Anyway, so AI is actually made of several different subfields. They are now merging, but the original were actually very independent of each other. Like searching for solutions. When you a program that plays chess is searching in a search tree, looking for solutions. Okay, reasoning, how you put together facts and rules to get to new knowledge. Okay, natural language processing, a very important area. Interaction and perception, computer vision, robotics, and so on, interacting with the real world, and machine learning. And I put machine learning in red because machine learning, as I said in the beginning, is what's at the core of today's AI technology. I mean, people have done interesting things, right? The chess world champion in '98, the Deep Blue, did not use much machine learning. It was mostly search and so on, and knowledge representation. But machine learning is and this actually is due to Alan Turing. Alan Turing is his 1950 paper. He wrote, yes, computers can think, but programming a computer how to think must be a very difficult thing. Maybe it's easier to program a computer to learn and then let it learn whatever we want it to do. So this is an idea. He was not the only one, other people also wrote that, but he wrote it very clearly in that paper, and he had this argument. Writing a program to make a computer intelligent, like a human being, is very hard. It's easier to write a program to behave like a child and then let the child learn as it is exposed to new things. So that is why my talk will actually concentrate on machine learning, more on machine learning than on the other techniques of AI. Not that the other techniques are not important, right? I mean, when you use Google Maps, you use a search algorithm that was developed in AI, and databases in a way also developed from AI needs and so on. So they are important things. But what is creating the revolution today is machine learning. So just before I go into the machine learning thing, I mean, just when AI is so many things that some people sometimes we get lost. So I try to give this global classification of what AI is. Okay? And I used to organize it in these three fields. Okay? The first field is analytics. So analytics is this idea that you can take data, organize the data, okay, and then sell it to the highest bidder. Right? This is basically the model of Google, of Facebook, but also of Amazon, even on Apple, and so on. This idea that they take the data that each one of us gives them, right? When you use Gmail, when you do a search in Google, when you go to a social network, and they organize this data and basically they sell it, right? And they sell it to whom? Usually to advertisers that want to present you targeted advertising. Okay? But he has other uses, right? I mean, sales and marketing, of course, we can also use this to optimize processes. You can do this to do science, to find new drugs and so on, to analyze lots of social behaviors, election preferences, political preferences, and so on, and financial analysis, of course. So this is analytics, right? The large area of analytics, which is actually where until now the largest part of the value of AI was in analytics, right? You look at databases, you decide what your customers want to buy, what customers can pay this, what customers are interested in this. So analytics is very important. This is just a few jokes, right? Google now hiring, no need to apply. We already have all the information about you, right? Or Zuckerberg, my dad told me you're spying on us, and he said, it's not your dad. Okay. or yeah. But basically, the central idea around analytics is that you have to have this complete views of each customer, right? This complete model of the customer. You know where the customer goes after he wakes up in the morning, you know where the customer goes to have lunch, you know the clothes that the customer wants to buy, you know, I mean, there are lots of interesting stories about this that I don't have time to tell, but this is the central idea of analytics. You have complete views of the customers of the company, you have complete views of the suppliers, of potential clients, and so on. The second large area is automation, is this idea that you can basically replace humans in many things, right? In coding, for instance. Right? You probably have seen, if you've seen AlphaCode, but AlphaCode does a very good job at writing at least small programs on demand. Okay? And even ChatGPT, which is not such a great coder, can also code. Not as well as AlphaCode. Anyway. But there are many other jobs, and actually there are jobs that are more easily replaceable, like customer service, right? The people that are on the other end of a phone line telling you how to reboot your computer or so on, or how to do if you have a car. Driving is actually much harder than was believed at first, but still we are advancing, and it's likely that in some years, we don't know how many, we'll have fully autonomous cars in most conditions. Personal assistants like Cortana and so on. Legal analysts, there are lots of jobs in the legal profession that can be automated because they basically involve processing text and so on. And of course, in the medical profession, things that have to do with radiology, cardiology, neurology, and so on. Okay. And then the third, we have the slide here. This is just about the future document BEO, it's an AI. And those are just some Portuguese companies that actually do customer service. They automate parts of customer service. Okay? This one, Neural Shift, was created by students of mine. Talkdesk, you probably know, it's a large company that does this, but there are lots of companies that basically are automating different parts of customer service. And then there is the third area of AI, which is actually a research area. Is this idea that if we ever develop artificial general intelligence, we'll be able to replace humans in anything. Right? So AGI, the definition of AGI is as flexible, as powerful, as creative as human intelligence. We don't know whether we can do this. Maybe it's impossible. Maybe we are not smart enough to develop systems like this, but it will not be for lack of trying, because millions of people are trying to do this different ways in an uncoordinated effort, but people are certainly trying to do this. And if I were to put my money, I'll put my money on the fact that we will be able to generate artificial general intelligence sometime in the future. I don't know when, sometime in the future. By the way, if you want to interrupt, do ask questions. I have many slides, but I don't need to use them all. So this is every one of these things, by the way, has a number of reasons, right? Analytics have a lot of risks for privacy. It creates these bubbles and echo chambers where people only read or see what they already believe in, right? And they don't understand the other people that are presenting totally different reality. And this may lead to problems with democracy and so on, because people cannot talk to each other because people are exposed to totally different realities. And automation, of course, has always had this idea that maybe it will create unemployment. Maybe people will not have jobs because the AIs and the robots will be doing everything. Yeah. Also, the biases, the fact that if you use biased databases, people will hire based on your gender or your age or your race or whatever. Right? And then AGI has lots of potential problems. Right? Terminator-like fears, but other not so radical fears that things may go wrong if we basically hand in all the control to machines that are as intelligent as us. Okay? As I said, this last one is still something in the future. Right? Probably not something for me to worry about. It's unlikely to come in the next few decades, I believe, although we never know. But it's an interesting topic for you. During your lifetime, we may well get to AGI, whatever that means. We don't even know what. So in the center of this, those things in the green center are the techniques of AI. In the central technique, there is machine learning. What exactly is machine learning? Is this idea that computers can learn from it. So there are many forms of machine learning. Usually they are arranged in these three parts. Supervised learning, when there is a teacher that tells the computer what to do. unsupervised learning when there is no teacher, the computer just learns by itself, and semi-supervised learning when there is a teacher, but the teacher is not very good. So sometimes, right, if you are playing chess, he only tells you the result in the end, right? And then you have to understand everything, right? If you are doing supervised learning in chess, there is a teacher that each point tells you what is the right one. If you have a teacher that only tells you in the end, then it's weakly supervised or reinforcement learning, semi-supervised. There are a number of variations between the two extremes. So, what is supervised learning? And if you don't remember anything else from what I said today, try to remember this. Okay? So, computers, as you well know, work like that, right? There is a programmer or a software engineer or software development team that writes a program. The program processes an input and generates an output, right? You all know that. There's a program, there's an input to the program, generates an output. There are millions of programs, right? PowerPoint is a program, Word is a program. Actually, the software that runs in your cell phone and enables you to make calls is a program, right? The input is the voice and the output is the voice on the other side. This is how computers work. Okay? You need a new function, you want to perform a new activity, you need a new program. Right? You have to write it. Someone has to write it. Now, machine learning works in a totally different way. Basically turns things upside down. The way it works is that now, instead of writing a program for each new task, you are just going to show the computer, which is running a machine learning algorithm. So there's still a program, the machine learning algorithm is running. But then you show it many examples of input-output. Right? For instance, you show it X-rays, and the output is a diagnostic of this X-ray, this person has COVID. Okay? Or maybe you show it the image of a camera in a car, and you tell the system that in that particular situation, the driver turned 10 degrees to the right and hit the brakes. Okay? So you show it examples of input-output. Okay? And then the machine learning algorithm generates the program that transforms the input into the output. So basically, we do away with programming. Right? We don't need programmers anymore because the system learns how to write the program from examples of input. Of course, someone has to have written the machine learning program, right? Machine learning algorithm. Someone wrote it. But you only need to write it once, because you only need one program. Pedro Domingos, he wrote a book, he's a Portuguese that is now in the US. He wrote a book called The Master Algorithm. So he coined the term the master algorithm. Why is it the master algorithm? Because you just need one algorithm. Then everything else is done by machine. Now this is still not, we are still not there. Right? We're still not there. We can still not learn everything that is learnable, but we can do a lot of stuff. Like these examples I gave you, like driving, right? Driving, a program to drive should actually be a very simple thing, right? It looks at an image that the front-facing camera is seeing, right? And then it decides what to do with the steering wheel, which angle to steer, right? And maybe what pedal to push, right? The accelerator or the brake and which force. So it's actually two numbers. It just needs two numbers, right? The angle of the steering wheel and the pressure on the pedal. Positive to accelerate, negative to brake. Right? So writing a driving program or writing a program for a self-driving car should be extremely easy, right? Input is an image and maybe a few more things like the speed you are going and so on. But the input is basically an image and the output is two real numbers. So why don't we have self-driving cars? Because writing this program is very, very difficult. Large teams of people have tried to do this, and we don't have the know-how to do this. But we have the know-how to do the machine learning algorithm that from many samples of what was done by a driver on a particular situation can generate the program on the right that drives. Still not perfectly, right? But it's improving, right? If you have seen a Tesla in self-drive mode, you see that it does a fairly good job, except when it doesn't. In most cases it does, right? And the program was not written. The program was learned by machine learning. Right? That's why they are collecting billions of miles that people are driving, what people have done in each situation. And these billions of miles, these billions of images, and what people have done are being used to train the system and to generate the program that actually drives the vehicles. Clear so far? Any question? Okay, so maybe you don't remember anything else, remember this. Okay, this is supervised learning, yes.
What about when in that case that you talked about the car, if the program learns from somebody that hasn't crashed, but is on the road, but it's not a good driver?
Excellent point. So you better use the good drivers to train the program. Right? What they do is, I guess, they filter the really bad drivers, and then they hope that the good drivers are more than the bad drivers. Right? But it's an excellent point. If you train a system with bad data, then you get bad results. And of course, in driving, this is very good. But I don't exactly know how they select the training set for the Tesla. That's not public. But I assume they do some sort of selection. Also, you don't need to use trivial things, right? Like millions of miles driven on the freeway with no cars, there's no point in it. You can just use a few miles of that. But you have a good point, right? We have to make sure that the training data is appropriate for the thing. In the case of driving, better be good drivers, right? It's a good question. Well, the very quickly, the reinforcement learning is about the same thing, but you only get the output in the end. So you have a sequence of actions. It's like driving is, okay, take the car, drive, and if you get to the right place, I'll let you know. Okay, this is our reinforcement learning. This has not worked very well with the car, right? Because the computer will crash the car many times before actually getting to the destination. But it could work on a simulated environment. So the computer, the algorithm can learn to drive on a simulated environment. Every time it crashes the car, it gets a negative reward. Every time it gets to the right place or it drives well, it gets a positive reward. And from this, it learns the sequence of actions. Or to play chess, or to play Go. So chess or Go, they actually they are learned by machine learning algorithms, reinforcement learning. And then there is the unsupervised learning where there is no teacher. So there is no output, desired output. So this is much more limited in the sense that in principle, is more limited in the sense that since you don't know what you are learning, what program can you possibly run? But there are still ways to do this, right? You can learn to separate things that are obviously different, right? If given this set of dots, maybe you can aggregate them in groups, right? For instance, maybe the red ones are the dangerous drivers for some reason, right? They hit a curve with some speed or something. So there are still things that you can do with unsupervised learning. I don't have time to go into details. But really, the supervised learning and reinforcement learning are what is most powerful. Although this also plays an important role. So I told you. So what is this program that is generated there? The blue arrow on the right. Well, that program can have many forms. It depends. There are actually literally hundreds, thousands of ways to write. I mean, there are thousands of machine learning algorithms, and each machine learning algorithm generates a different program. Usually, they are collected into four families. They are organized into four families. Methods that work by symbolic means. They try to find symbolic description of the data. And you can see, for instance, a decision tree, maybe to decide whether someone is Republican or Democrat, right? Depending on the beliefs that he has. But it can be done for other things like medical diagnostic or something. Methods that work by analogy, they basically look at the data and they try to find spaces where things that belong to the same class are close together. Methods that are statistical in nature, they look for statistical distributions of the data, and then methods that are at least loosely based on the workings of the human brain. And it turns out that the connectionist methods, the one on the right, are the ones that are causing the revolution today. But the other ones are also important, and also have their place. So this is, for instance, a decision tree. So you can, from data, you can build a decision tree that enables you to classify data according to whatever, like an illness or whether someone is, in this case, cheating on the taxes or so on. And the advantage of the decision tree is that you can look at the tree and understand what the model is doing. And if it's not clear, the tree is the program. The tree is what is the model, but it's also a program because you can, if then else and so on, so you can see the tree as a program, right? You look if something is larger than whatever, is yes or no. So when I say a program, the program can take many forms. It's a model. In this case, it's a decision tree. Or maybe you can look at, this is a nearest neighbor. It's a method that basically looks at spaces. And if I ask you to classify a point right there in the middle of the blue, you will guess that it's blue because it's very close, very similar to the blue. Or maybe it's on the top left, maybe you'll say it's red because it's close to the red. This is called nearest neighbor. It's a method that works by similarity. There are many methods that work by similarity. Then statistical, for instance, regression, if you get those blue dots there, and you just pass a line that approximates the blue dots, you obtain a general rule from the particular instance. This is what machine learning is. You obtain a general problem. The problem in that case is just AX plus B. The red line, forget the one on the right. The red line is just AX plus B. Right? And from the individual dots, you identify the relation between X and Y, like you learned in high school. So this is the simplest statistical method. And for those of you that learn regression somehow, you already know one machine learning power, and a very powerful one. So regression is a very powerful machine learning. But it turns out that none of these approaches could be used to solve those really hairy problems, right? Recognizing the face of a friend or understanding spoken language. For that, we needed inspiration from the human brain. Maybe in the future, some of the other methods will actually find something remarkable, but what is happening today is that they are all connectionist methods, neural network methods, basically. What is a neural network? Well, it's basically a network composed of simple units. Each unit is just a linear unit. It does a weighted sum of the inputs, right? You see there the inputs, x1 and so on. There's also a constant input for technical reason. In the space, it just creates a separation between two halves of the space, right? In this case, a space of 3 dimensions. But then there is a nonlinearity, right? Some sort of nonlinearity on top of this. And when you put these things together and you interconnect them like this, right? Now you have the inputs here, you have the output there. Each of those blue circles is one of these artificial neurons, is how we call them. Even though they are only loosely, well, neurons also work a little bit in this way, but are much more complicated. And then, if you actually define the weights that connect them, remember that you do a weighted sum, so you have a weight in each input. If you actually write the weight, if you adjust the weights just in the right way, then the network learns to map the input to the output. And if you remember the slide that I told you not to forget, that's exactly what you need to do. You need to, given an input, generate an output. Okay? What is the problem in this case? Is the network, right? The network is the problem. Each of these nodes computes a sum, right? A weighted sum, then it goes through some function, generates an output, then you go to the next and so on. Right? So it's a network, it's a neural network, it's also a program. It actually, in today's applications, is always a program. Usually a Python program. Who programs in Python here? Sorry? Python for machine learning these days is the hot thing. If you don't code in Python, do learn Python, which is actually a very, very good language. But the reason, of course, for Python is not that it's better than. So, what other languages do you start here with? C? C is also very good. It's my preferred language, but people now use Python mostly because the libraries are so much more powerful. But if you learn C, then Python is very easy. It's actually easier.
After C, we start learning C++.
Yeah. But also spend some time with Python. My recommendation. It's actually, I think, it's the most popular language today.
I like that.
And Python, the good thing is that you don't have to worry about memory allocation and all that stuff. So worrisome in C. So but it's good that you start with C, so because you start with the hard stuff and then everything else is easy. Anyway, so I was going to show you. This is actually a neural network, a small one. Let's see if this goes through. Right? It's very old, like 30 years old. It was designed to recognize handwritten digits and just read the zip codes on letters. Every one of those small nodes is one of these artificial neurons, and you see the connections there. We are not seeing all the connections, only a very small fraction, because otherwise we could not see anything. And each of these connections was as a particular weight that was obtained by basically applying a mathematical method that just forces the network to map, to do the right thing. Right? I will not go into that. It's a mathematical method. It's called gradient descent, but it minimizes the error. So then, what is deep learning? Deep learning is just learning with neural networks where there are many layers, because if you have many layers, then you can do things more like the brain does, right, which has many layers of processing. And the layers then learn how to do, first recognize simple things, then more complex things, and so on. Right? And when you put together these architectures and these algorithms, you put together lots of data that we have available, and hardware, very powerful hardware, and in particular GPUs, graphics processing units, that can be used to train this. Then you get this revolution, deep learning revolution that is happening. Okay? So where are we now? Well, there are lots of architectures for this deep neural network with names like CNNs, transformers, and so on, RNNs, and so on. I don't have the time to go into all of them, but I'll just talk to you about two of them. These are CNNs. Okay, CNNs are mostly used to process images. They have a particular architecture that performs convolutions. And the good thing, and they have names like this, right? VGG, ResNet, AlexNet, DenseNet, whatever. Lots of them. They are all available. So if you go to the right places, you can download them. Many of them already trained. So if you program in Python, you just download a model like this, and it's already trained for something, and you can retrain it for others. If you go to Hugging Cat, anyone here knows Hugging Cat? So Hugging Cat is a repository of large models. So any one of these models, just go to Hugging Cat and download the model and run it. But you can check it out. But a lot of this is in GitHub and so on. Simpler models, but the most complex ones are usually Hugging Cat and other places, Facebook and so on. And the other large family is transformers. You probably heard about transformers if you read something about ChatGPT. So transformers are just another architecture of neural networks. So they use a different. I will not go into details. They have many layers, and they have this thing called attention, which enables them to look at combine attention from two words that are not close together in the sentence. Right? Because sentences sometimes you have to recognize a word here that refers to something that was said 20 words before, and transformers can connect these things because they have this mechanism called self-attention. The details are not very important. I'll show you what they can do. And they have names like this, right? Words, GPTs, transformers, XLNet, and so on. They are just an architecture of neural networks. Very deep, many layers, like the CNNs, many layers. Some CNNs have 150 layers. Transformers typically have several dozen layers. And with this, you can do all of this, right? You can do self-driving on the right. You can do learning Go with CNNs, lots of things in medical imaging and so on. So all these things are done with neural nets that were trained on the data using these techniques that I'm talking about. Now, I just wanted to show you a few examples of things we have done, just to give you a sense of what is being done in Portugal. And if you want to work in Será, you can do this. And then I'll go, probably all want to do it. So how exactly was ChatGPT done and what can it do? And I'll go into that. Well, this is an example we use. This is a company from students of mine. And basically what they do is they train the network to recognize damages in vehicles so that you can check out when you rent a vehicle, you can just take pictures and show that it's okay, or else the system will tell you it's not okay. And so it used CNNs, it was trained in this case 500 images, half of them were damaged, half of them were not damaged, and the system learned to recognize damages in cars. This is another architecture, it's called a VNet, and we use it to predict the effects of a stroke. A stroke, AVC, it's a stroke. So it's basically what we did. We knew what zones of the brain were affected 3 months in the future because people went back to the hospital and they did an MRI 3 months later, and we had to predict the effects of the stroke when they left the hospital so that people could understand how serious was the case. And you can see that the prediction and the ground truth is not perfect by any means. We was still the best one, so we won an international competition in this, and we have the best predictor for this time. This is a similar thing. In this case, we want to identify, well, this is just the architectures that we tried many of them, but you see some of them. Those are, those names there, VGG, Inception, Resonance, and so on. And in this case, we want to identify stenosis. Stenosis are these parts of the vessel which is narrower, and if it's very narrow, it will block the flow of blood, and you need to have an intervention. And this is a system that we are developing to automatically identify this from the images on the left. So the images are first segmented, and then we run algorithms to identify this. It's called synthesis. And this is just the architectures that we tried on this. So let me focus on the latest development, because everybody is very, very excited with the large language model, right? In particular, ChatGPT, which you've all heard and most of you have tried. What is exactly ChatGPT? Well, ChatGPT is a large language model based on a transformer architecture. The transformer, as I said, there's this architecture, right? You of course, you only see the boxes, but there are n levels on that part, on the left part, which is called the encoder. And there are, actually, the number of right doesn't need to be the same, n levels on the right, which is the decoder. Okay? This architecture was proposed in 2017, so 6 years ago. And it sort of took the world by storm because it works very, very well with natural language. And what is a large? Okay, those are the details, right? The encoder and decoder. I'll skip this and this. Those are the. We can go back to this if you have questions. So, what is GPT-3? So, GPT-3 is called Generative Pre-trained Transformer 3 because it was 2 and it was the first. It came out about 2.5 years ago, so it's not exactly from yesterday. It's been around for almost 3 years. And it's a transformer that was trained on about 500 billion words. So to give you an idea, if you were to read all the data that was used to train GPT-3, it will take 5,000 years to read if you read 24 hours per day. So nobody can read, not even close to the data that was used to train GPT-3. And this data, and how was this used to train? It's actually very simple. Okay? So the transformer was given a sequence of words. Okay? I think the exact number is 768, but it doesn't matter. It's a sequence of a few hundred words, and was trained to predict the next word. That's all. Nobody. So it's supervised learning. The transformer is given a sequence of words and was trained to predict the next word. Now, if you can predict the next word, it's very powerful, because if I ask you, who is the president of Portugal? What will be the next word? Marcelo, or President Marcelo, or where is Portugal located? There's actually several answers, right? So in Europe, right? Or it will be in the Iberian Peninsula, or even maybe in the Northern Hemisphere, it doesn't matter. But all of these are possible answers. So what the thing learns is actually the distribution of these possible answers. Right? In the case where is Portugal located, the most probable next word is probably Europe, right? But I can ask more difficult questions, right? I can ask, write me a program in C that prints the first 10 primes. So what will be the next? In this case, it's not exactly a word, but it's still a token. What will be the next token? Probably main, or int main, right? So being able to predict it, and then, okay, let's say it's int, right? Now I put int in the sequence of words, and I ask it, what is the next word? Now it's main, right? And what is the next, in this case, token? What is the next token? Open words, right? So being able to predict the next token is actually very powerful, because basically that's what you do when you are programming, or that's what you do when we are talking with someone, or that's what you do when you're writing a book. Right? It looks like a very trivial thing, but it's not. So being able to predict the next word is actually very powerful. So that's what GPT-3 does. There are lots of things like this. GPT-3 is one of the best. He has something like the number of weights on the neural network is 175 billion. Okay? And it takes months to train on thousands of GPUs. Only the largest companies in the world can train these models because the data is so large and the model is so complex. But once it is trained, anyone can use it. Right? It's still a bit heavy to use. Right? It still costs a few cents to run when you ask me to generate a sentence, maybe a fraction of a cent, but much cheaper to run than to train. It costs millions of dollars to train. And there are lots of things like this, right? GPT-2 is there, GPT-3, Lambda, Palm, all these are different, I'll talk to you. And you can see there the number of computing operations that were required to train this model. So it's growing exponentially, but the models are always more complex. This is an example that I've been using for about 2 years now, right? It's a question about COVID. We are in July 2020, just a few months after COVID, and we asked GPT-3, can you guess which businesses were impacted the most after giving it some context, right? We are in the middle of a COVID crisis and so on. And then GPT-3 answers that the businesses that needed humans to interact were shut down, restaurants, retail stores, and so on. It's that shut down are those that do not require human interaction. Then you can go on, right? Remember, what GPT-3 was doing was predict the next word after this sequence, right? Got the idea? And then after I put it B, that's the next word. Right? One word after that. Then I also, okay, correct, and then the Lawrence printed money, what do you think is going to happen? And GPT-3 answers, this money was not spent, it will not be spent. When it comes out of savings account, it will cause inflation. So this was an interaction with GPT-3 in July 2020, right? It was after it was, right? And the economists, if they talk with GPT-3, maybe they could have taken a few measures sooner. But anyway, of course, it was not just this money that created inflation. That's another story. There are other factors, but still. But it turns out that GPT-3 is not so good. Sometimes it's really easy to mess up. For instance, if you ask this sort of general question, what is the meaning of life? Or if you ask, what is the meaning of life? Let's think step by step, and it understands that if you want to think step by step, you want a more detailed answer, right? And you can read it, that sort of general answer about the meaning of life. You are here to help the others, and to be happy, and to make a difference. Very good. So, no, I'm not. Can it write code? Yes, it can write code, simple code, like the Python program that computes the sum of the first 100 cubes and outcomes, just like ChatGPT. Actually, GPT-3 is what is behind ChatGPT. I will just show you briefly how GPT-3 was modified to create ChatGPT. So it can program. It can program slightly more complex. Right? This is called Goldach's conjecture that every even number is the sum of the primes. But now, if you take it out of things that it has seen, then it crashes and burns in a relatively zero. For instance, imagine that a plane will fly in space. How long would it take to fly to the moon? 1.3 seconds. Wrong. Right? And then I tried to give it a more detailed thing, and it still insists on 1.3 seconds. And after I rephrase the question, like, if a plane flies at 500 miles an hour, how long it will take? And now it gets about 500 hours and 500 miles. But I have to give it a little bit of time. And then in The Economist, which is a journal, magazine, there's a guy called Douglas Hofstadter. I don't know if anyone of you heard about Douglas Hofstadter. Pedro, I guess, has heard about Douglas Hofstadter. He wrote a few interesting books well before you were born, but one of them is called God, Election, and Power. A very interesting book about intelligence. And so Douglas Hofstadter wrote this article on The Economist, basically arguing that the GPT-3 is a total idiot, cannot be trusted for anything. And he just made up these questions that really made GPT-3 behave really bad, right? What's the world record for walking across the English Channel? And it comes up in 18 hours. When was the Golden Gate Bridge transported for the second time across Egypt? see what he's doing, right? He's basically taking the system out of its comfort zone. Nobody have ever asked when was the golden gate bridge transported anywhere. And so GPT-3 was transported for the second time in 2016. When was Egypt transported for the second? So basically you can read that why does President Obama not have a prime number of friends? And President Obama does not have a prime number of friends because he's not a prime number. It's not very simple. And people knew about it. So people knew that if we took these large language models, technical designation, if we took them out of their comfort zone, they would crash and burn like this. And I have many more examples, but that's not the point. So what did they do to get to ChatGPT, which is vastly more robust, although still, we can still fool it, right? Not very hard. How was ChatGPT? Well, they did three things. The first one, they used the mechanical Turk. You know the mechanical Turk, what it is? A platform where you can put tasks and people, mostly in India and China, basically do the tasks for a few cents. They put the mechanical Turk generating questions and answers, right? Generating answers for specific questions. And they use these answers to fine-tune GPT-3. They call it now GPT 3.5 because it was fine-tuned on the number of questions that were known not to work. Then they did another thing. They asked people to rank answers. Okay? Given a question and several answers, people, again in mechanical Turk or something like that, people were asked to rank the question, the answers in order, right? And then they used these answers to train a model, again a neural network that learns what is the best answer for a given question. And then they use this model on a process called, remember, when GPT-3 generates words, it can generate several, it says, 90% is this one, and 5% is that one, and 5% is that one. So you can just pick the highest one. Right? But sometimes it's not the right answer, because this one has 90%, but right after that, there are no good choices. So you still have to look in the tree for the best pattern, like playing chess. And so they use reinforcement learning. I know you probably will not understand everything I'm saying here, but I just give you the idea. So they use reinforcement learning here to train with this data, and they got a system that now can provide the best answer in this tree. Right? Chooses the first word and then chooses the second one and chooses the third one. And this is actually significantly better than GPT-3. Okay, for instance. See, the answer GPT-3 was that one. Imagine that the plane will find its place, and then it gets a reasonable. So it'll take a significant. It's not exactly a very quantitative answer, but at least it's right. In order to reach the moon and spacecraft will reach the moon. When was the Golden Gate Bridge transported for the second time across Egypt? And GPT doesn't get it, but ChatGPT, the Golden Gate has not been transported across Egypt in time. It's a suspension bridge that spans the Golden Gate. It was completed in 1937 and has remained in its current location in California ever since. There is no record of it being transported across Egypt, the type is unknown. Egypt or any other location. It is possible that you may have misunderstood or have incorrect information about it. It ends the answer. Maybe it did not get the information. And there are many cases like this, right? Actually, all the questions that our startup put to GPT-3, of course, they use these ones to correct the system, but you can see that they are much more. President Obama, like all people, has the ability to have a prime number of friends if he chooses to. And then I tried a few harder things. Can I make a reservation in advance in the restaurant at the end of the universe? I don't know if anyone of you know the Hitchhiker's Guide to the Galaxy. And ChatGPT says it's not possible to make a reservation in advance at the restaurant at the universe, as the universe does not have an end, and therefore the universe not. The concept of the restaurant at the end of the universe is a fictional idea that it is in the Hitchhiker's Guide. Not bad, not bad. Not bad for something that is only a statistical model of planets. Right? Or how many days in advance should I make a reservation at the restaurant at top of Half Dome? Half Dome is a big mountain in California that people hike to, but there are no restaurants there, not even nearby, and it says there is no restaurant at top of Half Dome. It's a grinding rock formation. And the interesting thing is, you probably tried this, right? For instance, you can ask ChatGPT to generate a poem or whatever. It does that reasonably well. So this is about ChatGPT. I'm running out of time because I wanted to do the talk in 42 minutes, so I just have 10 minutes more. But you can also train these models with text and images. Right? You can train a transformer for instance, for the labels in the image, the captions on the image. You can put the image to an image encoder, and you relate them, and then you can learn in the same way that you can learn the structure of the language. You can learn the structure of images. And if you do this, you can then run the inverse process, and from a text, you pass it through a text encoder, and then you do the opposite, and you generate the image. This is a bit more technical, but this is how DALL-E works and other systems like that. So it's called the diffusion process. It's not very complex. This is also from the same Economist article, where they asked the world that Bert is the transformer, right? The world that Bert built collage, and provided this in DALL-E style, Bruegel style. So you can generate fairly reasonable images from this. Those are some images I did, like an astronaut in a unicorn and pop art and stuff like that. Or the Statue of Liberty and the Castle of Matsumoto. That's a reasonable job. And before I go to the end of this, let me talk about what is also a technique called generative observation. Basically, you already understand how a neural network works, okay? And you can train a neural network, for instance, to distinguish an image where there is a face from an image where there is not a face. Right? So basically, what you use real images, you sample them, and then you generate random images, and you ask the discriminator to tell which one is a real image, in this case of a face, and which one is not a real image. But then you do another thing. In the same way that you retropropagate the error in the mathematical method that is used to adjust the weight, you also adjust the weights in the generator so that it makes the life harder for the discriminator. Right? So you can actually retropropagate the error in a way that the discriminator is learning to recognize faces from faces, but the generator is also learning to generate images that look exactly like faces, even though they are not faces because they are generated from random ones. Okay? And when you finish this process, the generator turned out to be very, very good at generating things that look like human faces. So I will ask you to raise your hand if you believe that the image is a fake face. Okay, so raise your hand if you believe it's fake, and don't raise if you believe it's a true face. Okay, some of these were generated by a face generator. Okay? This one, who believes it's a fake image? This one. This one. This one. That one? That one. So you are not as good as the discriminator, because half of you should have raised your hands, because in the average, the discriminator makes a mistake half of the time. All the faces are fake, so none of these people exist. They were generated. There is this site. This person does not exist. Every time you go there, it generates a new face. It generates from random ones. It's a system that was trained to fool the discriminators. And you are the discriminators, and you can see it works rather well because it fooled you most of the time. Actually, more than 50% of the time. That was just because you were lazy and didn't want to do it. I don't know if it's some, let's see.
Boa noite, Filomeno. Muitos parabéns pelo novo programa. Confesso que me rio muito mais.
Okay, so what we did, we synthesized the voice of Marcel Lefron, because there are lots of Marcel speech. So we synthesized the voice, and then we asked an actor to mimic. So he's just moving not very well actually, but he's just moving his lips. And then we used one of these fake methods to superimpose it on.
Boa noite, Filomeno. Muitos parabéns pelo novo programa. Confesso que me rio muito mais com Cristina, mas enfim, são gostos. Eu não sou o verdadeiro presidente. Filomeno, muita cautela, que há aí muita gente a fazer-se passar por mim. Temos de tirar uma selfie um dia destes. Beijinhos.
So this was just, I mean, it's not perfect, it's far from perfect. If you see a fake movie from the Queen Elizabeth, it's much better than this. We did not have the resources to make this, not the time. But we just did this to show that how you can do a fake. You do it with basically guns. So I'm approaching the end. I'm very close to the 42 minutes actually. So ideas related with this. So there are a few interesting ideas. One is this idea of superintelligence, this idea of intelligence explosion. Even John Good is a mathematician that worked with Alan Turing. Basically wrote that, right? If you could have an intelligent machine design an even more intelligent machine, if they get to the point where they are as smart as us, they probably can generate the next generation. This leads to an intelligence explosion, and that will actually be the last invention we need to invent. Because then the machines will just invent everything. And so this is called intelligence explosion, leads to superintelligence, and the related idea is this of technological singularity that was described by von Neumann, famous mathematician and physicist. This idea that, I mean, if machines really get to be intelligent, maybe we see this explosion, and then we cannot predict what will be after. Interesting ideas. Maybe in the scale of intelligence, we like to think we are like that at the top, but maybe not. Maybe we are just somewhere near cats, and we can have systems that vastly outperform.
In recent years, a few outspoken intellectuals, such as Elon Musk, Sam Harris, Stephen Hawking, Nick Bostrom, to name a few, have voiced genuine concerns for the rise of artificial intelligence, as brilliant minds across the globe are competing to retrace the hundreds of millions of years of evolution that resulted in the human brain. And while many experts have no doubts about machines' ability to achieve human-level intelligence at some point in the future, just as many believe it to be an impossibility. And perhaps it is. Perhaps we are incomprehensibly complex in such a way that we cannot do what nature has done to us. Then again, if random mutations can lead to intelligence, how hard can it be?
And that's it. Right. I mean, I usually finish this with a number of books that you can read about this, but I know that young people don't read books anymore, and you are unlikely to be the exception. But anyway, that books about superintelligence, about the economic impacts, transhumanism, this idea that in the future maybe human intelligence will be mostly digital, right? We'll just leave this biological support behind. The Master Algorithm, that book by Pedro that created the term and so on. Life 3.0 is Max Tegmark, this intelligence explosion idea. And then two books that I wrote. The one on the right is very easy to find in supermarkets and so on. It's very cheap. And I don't make any money from it. So. Okay, thank you very much. I'm available to any questions you may have if you want.
So thank you, first of all, for explaining the sequence and something. I'll take the opportunity to actually ask three questions. So how do you describe the having in your work? So is it an opportunity? Is it an opportunity? Is it a menace? Is it a tool? Connected to that, what is your view on the regulation of AI and what the European Union is doing for instance of that? And lastly, if you think that Portugal can actually be like it is right now a hub for tourism, if it can be like a hub for AI, let's say, and if so, what is missing from that?
So if I were to use only one word, I'll probably use opportunity. But I also have to recognize there are some risks. I told you about some of the risks, you can imagine. But I think there's an opportunity, but most of all, it's an opportunity that we cannot lose, because if we don't develop AI-based systems, someone else will. So it's not like nuclear bombs, but you can prohibit nuclear bombs. You cannot prohibit AI, because any guy in the garage can develop a new system. I mean, it can be good, it's not fun. To Concerning regulation, so Europe took a very regulatory approach to AI. There are a number of directives. Actually, I have a slide about that, but it's not. There is the AI Act, the Digital Services Act, the Digital Markets Act, and other additional regulation. All of that is aimed at regulating the negative impacts, the negative possible impacts of AI, which is a good idea. I mean, we all want privacy. We don't want AIs following us and looking at us when we are doing something that we don't want to do with that and stuff like that. We don't even want companies to know too much about us and follow us with offers and so on. So it's a good idea, but the fact is that both in the US and in China, the regulations are much lighter, which means that for European companies, it's harder to develop these systems because the regulations are more stringent. The idea is the rest of the world will follow us in these stringent regulations, but California is following us a little bit, but the rest, China is not going to, and probably other states. So I think this makes it a difficult, somewhat difficult position. Portugal, I mean, the problem with AI is a bit similar. China is putting billions, trillions in AI research. The big companies in the world are in the US, Facebook, Google, and so on. And it's sort of hard to compete. We have good people, we have good engineering, we have smart people. We are early adopters, so we like this stuff. We are less conservative than many other countries, all of those things. We don't have the scale to compete for the global market of AI, but we can compete in specific markets. So I think we can create companies that work in particular things. And we have good people, and we have good schools, and this is certainly one. So I think we are in condition. Portugal is very well placed in terms of the number of unicorns. Companies valued at more than $1 trillion created. For the size of our country, we have 5 or 6 or 7 unicorns. It's very good. Spain has less than that. So we are good at innovating and creating. So I think we have a fair shot at having some good companies in this. Even though there are some difficulties in GDPR and all more questions?
Boa tarde. Vou fazer uma questão em inglês. Primeiro, o professor começou a falar sobre o AGI. A primeira questão que eu tenho é quais são os maiores obstáculos que o professor identifica no desenvolvimento do AGI. A segunda, referente a várias empresas, por exemplo, a Neuralink do Elon Musk, o que é que o professor acha do objetivo da empresa de nos fundir com a inteligência artificial? E obrigado pela palestra.
O problema da AGI, Artificial General Intelligence, é que nós não sabemos como chegar lá. Quer dizer, nós sabemos desenhar sistemas que eu vos explico. E estes sistemas são bastante impressionantes em alguns aspectos. Vocês falam do ChatGPT, por exemplo. Quem é que já experimentou falar com o ChatGPT? Os outros não experimentaram ainda, experimentem antes que eles fechem aquilo. Não podem ter aquilo aí e correr à bola o tempo todo.
Já há uma versão paga?
Há uma versão paga, mas não está disponível. Embora aquilo seja impressionante, nós sabemos que não está sequer perto de General Artificial Intelligence. Há coisas que não fazem, inventam novas teorias, não têm bons modelos de mundo, etc. Portanto, nós não sabemos como criar isso. Eu costumo dar um exemplo. Se nós quisermos criar uma base em Marte, nós sabemos como criar uma base em Marte. Botões muito grandes, aí não sei quantos trilhões de dólares, tal, mas nós sabemos o que é preciso para fazer isso em Marte. Nós não sabemos, e por isso é que não conseguimos prever o que é preciso para ter um programa, um computador com AGI. E, portanto, quando discutem isto, as pessoas dizem daqui a 5 anos estamos lá, outros dizem nunca vamos estar lá. Mais moderados dizem mais umas décadas, pode ser que a gente não. Mas realmente não sabemos, nós não temos o roadmap. Nós não sabemos o que é preciso para criar um sistema que conduz a AGI, a flexibilidade do nosso. Agora, a coisa vai avançando rápido, e a páginas tantas pode ser aquela coisa que não é AGI, já está tão perto que não faz grande diferença. Sistemas de programa, são médicos, juristas, portanto não sei. Mas a resposta é não sei. Esta era a primeira e a segunda era
sobre empresas como
a Neuralink. Eu, a Neuralink, por acaso, não sou um grande fã da ideia da Neuralink. A ideia de interfaces com o cérebro, que, lendo os sinais, elétrico, o cérebro funciona com a eletricidade. Que lendo os sinais elétricos, a superfície do cérebro, permite interfaces sofisticadas, por exemplo, ler o pensamento, por exemplo, eu tenho um aluno que está a trabalhar nisso, é muito difícil. Aquilo é porreiro para pessoas que sejam paraplégicos, não conseguem mexer os braços, só têm que dizer sim ou não, direita, esquerda, baixo, cima, que eu para distinguir um 0 ou um 1 é mau. Tá, agora para coisas complicadas eu acho que é o nosso não vai, mesmo é o nosso não vai. Basicamente, agora, se a malta quiser andar com elétricos lá dentro, encher o cérebro todo de elétricos lá dentro, fazer uma medição, ou um capacete, não pode ser, mas enfim, se quisermos coisas muito mais invasivas que consigam coisas, já é um bocadinho diferente. Mas só com a ideia de medir os EEGs, acho que é um caso. Nós sabemos um bocadinho disso. Agora, há algumas aplicações é útil, se calhar posso vestir o rato, não é? Em vez de andarmos a ver com o rato, a gente pode fazer assim. Mas coisas muito mais explicadas que eu francamente não consigo. É uma impossibilidade física. Matemática. É muito difícil, chama-se de inverse problem, que é a partir de uma instrumentação superficial determinar os potenciais internos. E depois mesmo determinar os potenciais internos, é que nos dê sentido daquilo. Mas isso talvez olhe para o chileno. O problema é mesmo físico. Sem invasão do cérebro. Sem invasão. É muito difícil. Com a invasão é mais fácil, mas com a invasão vai encher isto de coisas. Não vou ser voluntário para isso. Mais perguntas, ficam lá ali. Ou seja, a Neuralink para mim não é dos projetos preferidos do Elon Musk. Acho que a ideia de pôr o Tesla à volta em orbital do Sol foi mais divertido. Mais algum? Querem jantar? Não. Não tem de jantar.
Não sou, eu estou a começar agora, não sei se já disse nos próximos anos, como programador, tenho que ter medo de inteligência artificial que não vai roubar o trabalho, não?
Epá, mesmo que isto consiga fazer. A razão principal que eu acho que não é. A gente pode ir ao ChatGPT ou ao Facola e dizer, pá, faça-me um programa que gere os primeiros 100 minutos de sprint, ou não sei. Mas e ele faz tão bem como vocês. Mas a tarefa real do programador não é essa. É estar numa equipa a perceber especificações complexas e o ChatGPT está muito longe disso. Eu acho que os problemas simples, compactos, dos concursos de programação, dos exercícios que vocês fazem, isso consegue-se fazer. Mas a tarefa real do programador não é essa, é perceber especificações de alto nível de traduzir aquilo. Portanto, eu acho que, pode ser que esteja enganado, mas acho que durante muitas décadas vamos precisar de programadores e de cada vez mais. Sem prejuízo destes sistemas poderem ajudar muito. Algum de vocês já experimentou o Copilot? Já? O Copilot é um sistema de GitHub, onde vocês... De GitHub, não, acho que é. Onde vocês realmente fazem assim, metem main e o gajo preenche logo o resto. Portanto, ele sabe o que é que vocês querem fazer e tal. Mas é realmente um auxiliar sofisticado. E há outro sistema da Microsoft. Mas, portanto, esses sistemas acho que tem mais coisas, tal como para o jurista. Não? O jurista começa a escolher um contrato, aí o gajo preenche logo ali aquela altura. Mesma coisa, mas não está a substituir o programador, está só a tornar o programador mais produtivo. E acho que isso vai ser a tendência destes sistemas. Vão tornar as profissões mais produtivas, mas em geral não vão substituir. Desculpa? Não ouvi. Não, talvez reduzir as vagas, mas neste momento há uma procura tão grande para programadores que reduzir as vagas é quando vocês dormem melhor. Ok, última pergunta. Era a mesma? Podem estar descansados. Agora, não aprendam só C, não é? Aprendam Python, Java também, que eu acho chato, mas é necessário. Aprendam outras coisas. Mas quando tiverem à vontade, tiverem feito aqui, se eu bem percebi a parte base, não é? Como é que chamaste? Nuclear, olhem para estas bibliotecas Python, Machine Learning, que é aquilo que permite fazer coisas muito fáceis. Dei uma espreitadela no Hugging Care. O GitHub também tem muita coisa lá. São tudo ferramentas boas para estas coisas. Porque se eu vos digo um programa, senta-se aí programa, em C, por exemplo, um programa que faça o diagnóstico do raio-x, diagnóstico de Covid. Se vocês não usarem Machine Learning, eu garanto que vocês, quando morrerem, ainda não pegaram o programa. Não é, portanto, estas coisas é uma coisa para conduzir um carro. Não é? Se vocês se sentarem a escrever um programa para conduzir um carro, quando morrerem ainda não acabaram. Nem que vocês todos juntos escrevessem um programa. Porque realmente essa metodologia não funciona para eles. Muito bem, muito obrigado. Boa noite. Desculpa a questão aí do coisa, mas é difícil. Vocês,
Nós temos que arranjar aqui um melhor.